Hello viewers, this is Wagda Ronald taking you through this tutorial for A-Level Applied Mathematics. And this video we're going to talk about a topic of Newton's laws of motion, and we're basically going to go through the assignment left in the previous video. So this topic is still under mechanics and is suitable for students in both senior 5 and senior 6, offering principal mathematics as part of their combination. Now these are the very questions I left in the previous video, so I believe by now you have already tried them out and ready to mark yourself and check your progress. So now we shall start with question 1, which says that find the constant horizontal force which would give a body of mass 5 kilograms at rest of a smooth horizontal plane a velocity of 10 meters per second in 4 seconds. So this would have been on, so the body is on a smooth horizontal plane. So the first thing to do is to, since we have the initial velocity which is 0 and final velocity which is 10 and the time taken which is 4, we can get acceleration from there. So we shall come and substitute and get our acceleration as 2.5 meters per second squared. So now that we know acceleration, we shall come and draw our sketch. So first of all, we have to remember that the body has mass of 5 kilograms, therefore the weight will act vertically downwards of 4g. Then because of this weight, there will be normal reaction, which is capital R. Then they want a constant horizontal force, so let that force be capital F. And therefore, because it's in that direction, the body will move to the right. So with that, we shall come and resolve parallel to the plane. So when we resolve parallel to the plane, this is the only force acting, so we shall use F equal to ma. So F will be equal to ma, and we know that mass is 5 and acceleration is 2.5, therefore our force will be 12.5 newtons. So basically that's what they wanted, and now let's see how mass can be awarded. So B1 for the correct force diagram drawn using a ruler, M1 for substitution, B1 for acceleration, M1 for substitution, A1 for force. Now we shall go to question 2. Question 2 says a particle of mass 5 kilograms is moving with at a steady speed of 15 meters per second. Steady meaning it is constant. When it meets with a fixed resistance of 10 newtons. How long does it take to come to rest? So in other words, the final velocity will be 0. So you first make a sketch. The particles of mass 5 kilograms, therefore the weight will act vertically downwards of 4g, and because of this weight there will be normal reaction R. Then there is a forward force which is 0 because they didn't talk about any force pulling the body. They just saw that it's moving with a steady speed. That's why you put here 0 newtons. Then the opposing force, they told us that there is a resistance of 10, so this force must be opposing the motion, so it has to be in the opposite direction. And the acceleration is to the right. So with that, we can now resolve part of the plane. So when I resolve part of the plane, I realize resultant force must be in the direction of motion, therefore it will be 0 minus 10. That will be your resultant force equal to ma. So you come here and say that from F equal to ma, this resultant force will be 0 minus 10, which is this, equal to m, which is 5, and a, which is unknown. Therefore, I think a is the only unknown. When I make it the subject, I'll come up with a being equal to negative 2 meters per second squared. Note that there is a negative, meaning there was deceleration. So now that I've got A and I know U and I also know V, that means I can get the time taken. Therefore I come here and say that from first equation of motion, my V is 0, my U is 15, and A is negative 2. Then when I substitute, I'll come up with that, and when I make it the subject, I'll come up with t being equal to 7.5 seconds. So basically that's what they wanted, and now let's see how mass can be awarded. So B1 for the correct force diagram drawn using a ruler, M1 for substitution here, A1 for the B1 for acceleration, M1 for substitution, A1 for the time which is required. So basically that's how the 5 marks could come about. Now we shall go to question 3. Question 3 says that when a horizontal force of 14.7 newtons is applied on a body of mass 4 kilograms, which is resting meaning velocity is 0, on a horizontal rough plane, know that word rough, the body is found to be in limiting equilibrium, know that word limiting equilibrium. Calculate Roman 1 the coefficient of friction between the body and the plane, and Roman 2 the angle of friction. So limiting equilibrium, what does it mean? Limiting equilibrium means that the particle is just about to slide, or is not that word that limiting equilibrium means that the particle is just about to slide, meaning that acceleration is still 0 but at the point of moving. So the first thing to do will be to make a sketch. So we know that the particles of mass 4 kilograms, meaning that weight will act vertically downwards of 4g. And because of this weight, there will be a normal reaction, capital R. Then they told us that there was a forward force which is horizontal and it's 14 newtons, so that's, we shall come and put there 14.7 newtons. Then there was, because it was rough, there will be friction, which is mu R. So mu R stands for friction force, where mu is the coefficient of friction and R is the normal reaction. So that means that because friction is in this direction, acceleration has to be in the opposite direction. Therefore, I think you see that we have put acceleration equal to 0 because it is not yet moving but is just about to move. So before I go to the next slide, we can give a mark for this B1 for the correct force diagram drawn using a ruler. Now part B, they wanted the coefficient of friction. So coefficient of friction is got by resolving horizontally or resolving part of the plane. So when I resolve, you realize that this 14.7 minus this will be equal to MA, but A is 0, meaning that this is equal to that. So I'll come here and say that resolving perpendicular to the plane, first of all, R is equal to 4G, where G is 9.8, so when I substitute, I come up with R being equal to 39.2 newtons. So now that I've got R, I can now resolve part of the plane, whereby I'll say 14.7 is equal to mu R. Now R is 39.2, therefore when I substitute, I'll have only mu, which is unknown, and when I make it the subject, I'll come up with mu equal to 0.375. So that was Roman 1. Now let's go to Roman 2. Roman 2, they want the angle of friction. So angle of friction is always equal to arctan of mu. Always remember that angle of friction is equal to arctan mu, where mu is the coefficient of friction. So arctan of 0.375 will be equal to 20.5560 degrees. So that's what they wanted, and now let's see how mass can be awarded. So M1 for substitution here and A1 for output, which is required, M1 for substitution and A1 for output. So basically that's how the 5 marks could come about. Now we shall go to question 4, which came from UNEB March 1998, paper 2, question 2, and it says a carton of mass 0.4 kilograms is thrown across a table with a velocity of 25 meters per second. The resistance of the table to its motion is 50 newtons. How far will it travel before coming to rest? That is question 1. Then another question is that what must be the resistance if it is to travel only 2 meters? So we shall start with the first question: how far will it travel before coming to rest? So when it comes to rest, it means that final velocity is 0 and initial velocity is 25. And resistance or opposing force is 50 newtons and weight mass is 0.4 kilograms. So you come and first make a sketch. You know that mass is 0.4 kilograms, therefore weight will be 0.4 g. Because of this weight, there will also be normal reaction error. Now they didn't talk about any force pulling it, which is constantly pulling it, therefore forward force will be 0 and opposing force will be 50 newtons. Then the direction of motion will be to the right. So now we shall start with F equal to ma. That means that we are going to resolve horizontally, therefore 0 minus 50 will be the resultant force. So we shall come here and substitute that 0 minus 50 is equal to m, which is 0.4 kilograms times acceleration. And I think we realize that a is the only unknown. Therefore, when I make a the subject, I'll come up with a equal to negative 1.125 meters per second squared. So now that I've got acceleration, I can use third equation of motion to get the distance moved. So distance will be equal to v squared minus u squared over 2a. So v squared is v0, u is 25, and a is 125. So this is negative 125, so there's a negative here. Now this negative and this negative will cancel, that's why we have a positive here. So that was, before I go to the next slide, let's see marks for this slide. So B1 for acceleration, M1 for substitution, and A1 for output. Now we're going to part B, which says that what must be the resistance if it is to travel only 2 meters. So you come and say that if it is to only travel 2 meters, let small f be the new resistance. Therefore, acceleration will now be equal to v minus u over 2s, where s is 2 meters. So when I substitute, I come up with my acceleration being equal to negative 156.25 meters per second. So I come and draw my sketch. So there is a weight of 0.4 g, and because of this weight there will be no more reaction, and therefore the forward force is 0, but the resistance is F. Then direction of motion is to the right, and it has an acceleration of negative 156.25. Therefore, when I use F equal to ma, it will resultant force will be 0 minus F, which is that equal to ma. But I know my m is 0.4 and my acceleration is negative 156.25. so 0 minus f is the same as negative f. So when I think you'll see that I have only f, which is the only unknown. Therefore, when I make f the subject, it will be 62.5 newtons. So this is the new resistance if it is to only travel 2 meters. So with that, we shall see how mass can be awarded. So B1 for acceleration, M1 for substitution, A1 for output. So basically, that's how the 6 mass could come about. Now we shall go to question 5, which says that a block of mass 5 kilograms initially at rest on a horizontal surface is acted upon by a horizontal force of 20 newtons. The block covers 20 meters before the force is removed, and then decelerates uniformly from a speed of 8 meters per second it had attained to rest. Find part A, Roman 1, the frictional force, and Roman 2, the distance the block covers during deceleration. So with the force still acting on the body, on the particle, we shall say that u is 0, s is 20, and v is 8. Therefore, the acceleration, which is a1, the Now this A1 is the acceleration when the force is still acting. It is equal to v squared. This is now third equation of motion, v squared minus u squared over 2s. So when I substitute v is 8 and u is 0, then s is 20, therefore acceleration will be 1.6 meters per second squared. Now that I've got acceleration, I can now make a sketch. So the weight will be 5g, and because of weight there will be normal reaction r, and the forward force was 20 newtons, and the opposing force let it be F. So the direction of motion is to the right and the acceleration is A1. So now we are going to resolve part of the plane. So part of the plane implies that this forward force, which is 20 minus F, is the resultant force, and to be equal to MA1. So you come here and say that 20 minus F is equal to MA1. But I know that M is 5 kilograms, therefore I'll come and substitute, and I'll remain with only F, which is the only unknown. Therefore when I make F the subject, I'll come up with F being equal to 12 newtons. Then for Roman 2, with the force removed from the particle, it implies that U is now 8, V is 0, because they told us that it comes to rest. So the first thing to do is to make a sketch. So the particle is of the weight 5g, and because of the weight there will be a normal reaction, which is R. Therefore the force was removed, that's why here the forward force is 0. But the resistance is still there, which is F, and the direction of motion is to the right. And now the acceleration has also changed, it's now A2. Therefore resolving part of the plane, you realize F0 minus F will be equal to MA2. Therefore I know F as 12 from the previous question, from the Roman 1. M is 5, therefore A2 is the only unknown, therefore A2 will be equal to negative 2.4 meters per second squared. So now that I know A2, I can use third equation of motion to get the distance. Therefore V is 0 and U is 8 and A is negative 2.4. Therefore when I substitute, I come up with 13.3333 meters. So basically that's what they wanted, and now let's see how marks can be awarded. But before we award marks for this slide, let's look at the first slide because marks were not awarded. So for this slide, B1 was for acceleration, M1 for substitution, and A1 for output. Then for this slide also, B1 for acceleration, M1 for substitution, and A1 for output. So basically that's how the 6 marks could come about. Now we shall go to question 6, and question 6 says a boy pulls a box of mass 20 kilograms by means of a light inextensible string attached to it across a rough horizontal ground. The coefficient of friction between the box and the ground is 0.25. If the string is inclined at 30 degrees to the horizontal, and the box accelerates at 2 meters per second squared, find the tension in the string. So the first thing to do will be to make a sketch. So the particle has mass of 20 kilograms, therefore weight will be 20g, and because of this weight there will be normal reaction upwards, which is R. Then the force was inclined, the tension was inclined, because they told us that the string is inclined at 30 degrees, so this is 30 degrees, and this will be now the tension in the string. Now before anything, we have to first find the components of that tension. So the horizontal component will be T cos 30, because this 30 lies on the horizontal, therefore the horizontal will have cos. Then the vertical will be T sin 30. the direction of motion is to the right, and they also told us that the ground is rough, therefore there will be friction acting to the left, and to be mu r, where mu is 0.25 and r is this normal reaction. So before we go to the next slide, we shall give B1 for this correct diagram, first diagram drawn using a ruler. And now let's go to the next slide. So resolving vertically, so if you look at this, vertically there are two forces. Upwards there is r and t sin theta, t sin 30, and downwards there is 20g. So we shall come and say that r plus t sin 30 is equal to 20g, and g is 9.8. Therefore come and substitute, then I'll remain with r in terms of t, therefore r will be equal to 196 minus 0.5 t. Then resolving horizontally, if you look at this first diagram, horizontally there is a force to the right which is t cos 30, and force to the left is mu r, and there is an acceleration, therefore the resultant will be t cos 30 minus mu r equal to ma. So you'll come here and say that t cos 30 minus mu r is equal to ma, where m is 20 kilograms. But I know r is equal to 196 minus 0.5 t, so I'll come and substitute for r and for mu, because mu was 0.25. So when I substitute, I'll come up with that line, and when I simplify, I'll come up with that. At this point, I've put multiply 0.25 by 96 to come up with 49, then 0.25 by 0.5 to come up with 0.125. Then 20 times 2 is 40. Therefore, when I simplify, this 49 can go this side to come up with positive, therefore 40 plus 49 will give you 89. Then this, because of this negative and this negative, it will become positive, so cos 30 plus 0.125 will give me 0.9910, and this t which is there. Now when I make t the subject, I'll come up with t equal to 89.8083 newtons. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for substitution, B1 for making out the subject, M1 for substitution, and A1 for getting the tension. So that brings us to the end of this lesson. Thank you for watching, and be reminded that the next video will be on motion on smooth and rough inclined planes. So if you have not yet subscribed, please click on the subscribe button below this video so that I can receive updates when the next video on motion on smooth and rough inclined planes has been uploaded. So this video has been on smooth and rough horizontal planes, but the next video will be on smooth and rough inclined planes. Also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.